This video is to review Unit 3, Lesson 3.1, Solving Systems of Equations. So there are 4 methods for solving systems of equations: graphing, numerical, substitution, or elimination. When we're looking at the graphs of equations, we can either have intersecting lines, parallel lines, or lines that coincide, which means it's the same line. If we have intersecting lines, we'll have exactly one solution represented by an ordered pair x, y. If I have parallel lines, those lines will have the same slope, and that will mean I have no solution, which can be shown by a symbol as a 0 with a line through it. Or if I have coinciding lines that have the same slope and the same y-intercept, that's going to give me infinitely many solutions. And in red there, that little sideways 8 is the infinity symbol. So in this first example, Henry wants to join a book club, join a book of the month club. The first club cost $40 to join and $10 per book. The second club costs $15 per book and has no fee to join. How many books would need to be purchased from each club for the clubs to cost the same? So the first thing we need to do is define our variables. So here, X is the number of books and Y is money. And we know that because our problem says $10 per book. That word per is telling us that our rate is $10, and that would make the variable X books. So if we're writing the equation based on the information we're given for the first club, our equation is going to be y equals 40 plus 10x, because our flat fee to join is $40 and our variable rate is $10 per book. And our second club is y equals 15x. We don't have a y-intercept for our second club equation because there is no fee to join. So if I want to use a table method, I would want to enter both of these equations in y equals and either go to the table on my TI-83 or create a table in Desmos until I find the x value where my y values are the same. If I'm going to do this graphically, I would want to find the intersection of the graphs. So if we type that in Desmos, the intersection will show up as a gray dot, and we can click on that dot to find out what the ordered pair is. Or if I'm doing this in my TI-84 calculator, when I type in y1 and y2 into my equations, when I go to the graph, I'll need to use the settings to find the intersection by going to second trace and then find intersect, and we'll want to follow the directions for how to use our graphing calculator to do that. I'll go over those examples in another video. If I want to do an algebraic solution, I could use substitution. Because I have y equals for both of these equations, that means I can set them equal to each other because they're both equal to y. And I'll solve for x by subtracting 10x and then dividing by 5 to find that x equals 8. So when I buy 8 books, my cost will be $120. So for our steps for solving the systems, we need to solve for y so we can have our equation in slope-intercept form. And remembering that our slope is rise over run and the b value is our y-intercept. Then I'll need to graph each line, starting with the y-intercept and then using the slope to find other points on the line, and then finding the point of intersection. So we do need to be able to graph these by hand if we're given graph paper, but we also need to be able to do these in Desmos or the TI-84 on your Chromebook. Some other examples here, I had to solve both of these equations for y. These were both given to me in standard form. After I put them in slope-intercept form, I see that my first equation, x plus y equals 6, is going to become y equals negative x plus 6, which means my y-intercept is 6 and my slope is negative 1. For my second line, I'm going to get y equals 3/4 x minus 1, which tells me my y-intercept is negative 1 and my slope is positive 3/4. When I graph this by hand, I find that the intersection of these two lines is the ordered pair 4, 2. We need to make sure that when we copy these notes into our packet that we are being precise with our lines, and we need to plot at least 3 points. So notice on the graph that my red line has 3 points very clearly plotted neatly. So you need to be using a straight edge to draw these lines, whether it be your edge of your notebook or a ruler or anything that is going to give you a straight edge. For our next example, we solve these two equations to get y equals 4/3 x minus 3 for both of these equations once they are fully simplified. So make sure that if you have coefficients that you simplify those coefficients. And when we have this same line, this tells us that we're going to have infinitely many solutions. Pause the video now if you need to finish writing example 2. For example 3, when we solve both of these lines, we get y equals negative 2/3 x plus 2 and y equals negative 2/3 x plus 3. These lines are parallel, which means they will never intersect, which gives me no solution. If we're solving these using a graphing calculator, so here are the steps that I mentioned before. So we'll make sure that we have our equation solved for y to type them into y1 and y2. We'll click zoom number 6 for a standard view, or we can just go to our graph. And then to find the intersection, we'll do second trace, which will take us to the calculate menu. Number 5 will give us our intersection, and we'll need to hit enter 3 times, and then it will give us our x and y values at the bottom of the screen. That brings us to the end of our video notes for Unit 3, 1.1.